This red color line is what along which the detector is moving. Okay, we do have two sources. Separation between them 7 lambda by 2, where d very much greater than lambda. Immediately first what we see here, minima, no? We notice here minima. The minima will be noticed here. Some other color, let me pick up. This will be minima. After minima, what do we get? We should get a maxima. Then okay, let me begin like this. Minima will get it. Okay, next again one minima. Seven lambda by 2. So this will be 3 point, like a path difference. How much will be? 7 lambda by 2 will come. This path difference of this will be 5 lambda by 2. 3 lambda by 2 and lambda by 2. So one more. One more, I'll put it here. Count it, how many are there? 1, 2, 3, 4, 3, 3 plus 1. So how many? 7 minimas will be there. What about, what is the position of this? Where do it will be? Almost at infinity, no? This will be lying at infinity. This will be lying at infinity. Okay, no, don't write. Okay, let it be. Infinity will come afterwards. It should be like that. Huh? 3 lambda by 2. Afterwards, this will be lambda by 2. Similar on this one. 5 lambda by 2, 3 lambda by 2, lambda by 2. Then comes the infinity. So as you move from minus infinity to plus infinity, you are going to see how many minimas are there? 1, 2, 3, 4, 7. Answer should be 7. Simple objective questions. So I suggest you don't touch interference. What all you studied wave optics, that is enough. So take out interference from this. Then focus. So Doppler effect, you get wide varieties of question. I think that's the only topic which may trouble you in exam. The rest all you can manage. We do have let's assume that there's a ground. Actually, a Wiggle of frequency. Wiggle means source only. So it will be dropped above the height. Let this be capital H. I'm trying to construct a diagram, and a detector, it is projected with a velocity, say like with a velocity V0. Let's assume that one. Detector or VO, VD, anything you can write it. This what at t equals 0, they are here. This is t equal to 0. Strictly what is telling, at the same time, along the same line, if the velocity of sound is, find the frequency detected by detector after t equal to 5 seconds. At t equal to 5 seconds, what happen? The wave will reach detector and it will be detected. So this will undergo retardation. So somewhere at t equal to 5 seconds, no need to construct diagram. If you are really able to imagine, no need of this one. I feel no need of constructing diagram also. So detector will be somewhere here, no? V2, I'll write it. So VD2, velocity of detector. Now, when the source, the moment will it be generated? You can see now 505 meter. So when somewhere when the source is here, it would have generated, no? And detector will be somewhere here. Let's, I think this I'm not interested. Anyway, so there's a time at which the wave will be generated, and there's a time at which, and somewhere source let it be. For your understanding purpose, there's a time. So at this instant of time, signal will be detected. Here, the wave pulse will be generated. I think one problem we have discussed. So with gravity is what we are introducing this concept here. So here the signal what happened has arrived at the detector. It was generated at a frequency f. It will be received at a frequency. What is the thing? F naught. It will be receiving at a frequency f. So we are very sure now at what instant of time generated, we don't know. Signal generated, you write it. Signal detected. It will fall through height, say h1. It will rise to an height h2 for detecting signal. And what is the distance? There's a distance moved by the source to detect a signal, to read the detector. Let me write distance moved by the wave. So what is that capital H? H1 plus SW plus H2. H2 we know. SW, speed of the sound, we don't know this. We have to calculate. Somehow if you can calculate T1, problem is solved. So first, why we should calculate T1, T2? Let's see, let's go for Doppler effect formula. F equal to F naught, speed of sound. See, if the detector approaches this one, it should be positive, no? If the source moves towards detector, it should be negative. I think we have to adjust the speed of that one. And since they're along line joining, no, this one. So what is VS1? Speed of the source when signal generated. What is VD2? Speed of the detector when signal detected. So what is VD2? We know it. VD2 is equal to V0 minus GT2. So this should be equal to 50 minus 10. So only thing is VS1 is needed. So the time at which signal is generated. How to calculate that one? Can we calculate first H1? GT1 square by 2 or 5 T1 square. Can we calculate H2? H2 equal to V0 T2 minus GT2 square. So V0 is how much? 50 T2 minus 5 T2 square. Keep it in and this one. Then what is the velocity? Okay, anyway, like a VS1 is needed. So VS1 will come only when you know the T1. So that if you substitute, our answer will come. So we don't know this VS1. To know that VS1, we should know T1. So how to bring T1 is what all our entire discussion know. So what is that capital H looking at diagram? Capital H should be equal to H1 SW plus H2. How much of time the wave will take to move from source to detector?
T2 minus T1.
T2 minus T1. So speed of the sound. Okay, this we know 50 T2. Okay, I think we can calculate this value. Anybody? T2 is fine, no? 2,500, 2,500, 125. 125? Five T1 square, 300, 5 minus T1, 125. Total height is 505. Solving for T1, quadratic equation will get T1. Once getting T1, anybody T1? There's a mechanism. So Doppler effect, just you have to be alert. Take help of kinematics, nothing big. It can be mixed with any other concept. Okay, anybody? 4, okay, good. Okay, this value, what will happen? Now I'm going to substitute here. I'll get the apparent frequency. Apparent frequency detected by detected. No, if not, I think we have to substitute all values. 1,300. BS1 will be 10 into 4, 40. 1,500 will come. Some mixed with gravity idea. So you do one thing. You do get a Doppler effect questions where signal generated at that instant, signal will be received, or the time at which signal generated and detected will be different. So how do I come to know? I think that is what you should make observation here. That's what you have to make observation in a question. I think this is the thing. Difference is what you try to notice in every problem. The time at which signal generated, will it detected instantaneously, means at that instant only. In that case, open the distance between source and detector, they're very small, with some less than like a 300 meter or 10 meter, no? Okay, at that instant will be detected. If the distance between source and the detector is more than 300 meter or 400, 500 or 1000, 2000 or 2, 5, 10 kilometer, no? Definitely the sound wave should take some time to propagate. So therefore the time at which generated, detected will be different. This you identify this aspect, it'll be easy for you. So it's a similar concept. There it was acceleration. Now don't think that only in acceleration